Today's topic, this is network policy and access services. A lot of what this is about, it does have a policy. The policy is like the last thing that you do, access policy. A lot of what this is about is configuring routing on this thing and NAT on the server itself. The book calls for you to install a second server. You don't have to do that. I'm going to show you the topology that I want you to use here in a minute. I've given you a second XP machine on the quote public network, unquote public network. You can use your existing core server to do the other stuff, because all I ask you to do is ping to see how far you can go. Can you go through? Is the process working correctly? The other XP machine should be used predominantly to do the VPN. So there are some issues. I have changed the topology, and the topology is in the lab sheet, different from the topology that's in the book. But you should be able to see it there. The objectives: configure routing in Windows Server 2008. Not something that you're probably going to do on a regular basis unless it's a relatively small organization. I use it on a regular basis for the virtual machines because that's what runs on a virtual machine. That gives me the ability to isolate the virtual machines from the rest of the network. We could, and obviously have, because the XP machines that you have are going to be on the quote public unquote network, the ECPI, the Skyline network, the 10.60/64 network. And then you'll be able to go back into your server, and once you get the VPN to the server and then to the backside, to be able to connect securely through these things. Configure routing and remote access services in Windows Server 2008. Mostly what configuring and installing is right-click configure. Another change that, and it's in I think I put it in the lab, when you install the service, I want you to install LAN, NAT, and VPN at the same time. What they have you do is install routing and NAT on one server, do the exercises, and then put VPN on the other server. We're only going to use one server. You can't add these things after you get it configured. If you want to add something, you go back and start over. So instead of going back and starting over, just put, and I'll show you how to do that, just put all the services on up front so that they're available when we get there. Describe the network policy server. The network policy server is a connection server, and you should have Active Directory on these machines. The default access, and when we talk about policy server here, they got a couple of different policy servers that we talk about. This policy server is a remote access policy server, and we'll do a remote access policy. I take you through, have you manually change it, and then go back and do the policy of who you want to be able to get on the network. Discuss wireless network in Windows Server 2008, and what the wireless mostly is using a radius server. We're not going to configure it here. I have a lab in the security class where you configure a radius server and use it for authentication in order to get on a wireless access point. I posted a video. It's a step-by-step on how to do that if you want to take a look at that. It's about 12 or 13 minutes. It shouldn't take that long to watch. But it goes through how to configure, and it uses Server 2003, but the process is the same. The clicks are in a little bit different location. The process is the same so that you can configure a wireless access point. It's a little D-Link to use a radius server and Active Directory in order to authenticate users to actually get onto your wireless access point. And as you hopefully may recall, as you may recall from routing, you can also use the 802.1x protocol on switches so that the switch ports don't turn on until you actually authenticate. Gives you a little bit more security. It's not I won't say the simplest thing, and it's not the simplest thing to configure on a switch. It's pretty straightforward, I thought, on the wireless access point. So if you would, at some point, dedicate the 12 or 14 minutes, actually I think it's 13 minutes or something, to look at that video. It goes through how to configure 802.1x. Routing and remote access services is a role service used to configure and manage routing in Windows Server 2008. The activities in the book you can use them in order to get the services set up to do the things that we've asked you to do there. Recommended for use in small networks that require simple routing directions. I don't know who's going to use a Windows server. How much does a Windows Server license cost? Anybody looked at it? A lot. So you're going to set up this Windows Server that costs a lot as a router? Not as a dedicated router, I'm pretty sure. You can use it temporarily. You got another machine running with 2 NICs. You can install the service and use it as a router. But I'm not sure that from a practical standpoint, if you have to do all the licensing, that it's a great thing. And the web server, the cheap one, won't run that way. I'll be heretical here. If you're really going to use one of these things, go get a Linux machine. Okay, but now that we've said that, you got to know how to set this thing up, because hopefully at some point in time you're going to go get that MCTS or MCITP, so that you can go, when you go out of here, and go say, yeah, I've got a Microsoft certification. They help. They really do help a lot. I know I keep pushing those things. Not recommended for larger complex environments. One of the things that happens is a router is a router. A router is configured, is optimized to do routing. A Windows server is not optimized for routing. It's not the greatest server in the world. So for heavy loads, it would be not very practical. You can use static routes, and you can use dynamic routes for RIP. It used to have, I think, OSPF in it, but they took it out in Server 2008. So it has RIP v1 and RIP v2 if you want to share routes using RIP. And going back to routing with all that broadcast going on, would lock us into the small networks that require a simple solution. It's really very easy, and I want to go through the steps after we get through with this, how to install it, how to install the routing, make the routing work, how to install NAT. All of it is clicky, step by step. Conceptually is where you really need to know where these things go. Remember in Cisco was three commands, I think? Actually 4 commands, because you had to label the inside and the outside, and then you had to give the NAT commands, the pools and everything else in order to do that. You do the same things here, but you don't have to do it at the command line. It all runs through a GUI. Routers had routers responsible for forwarding packets on networks with differing IP addressing schemes. Let's say with a different subnet mask, on a different subnet. Routers find networks. ARP finds resources. ARP finds the MAC address for the individual device that you're trying to go to. This is the topology that I've got set up for this lab. The added machine is a Windows XP machine. I gave you the instructions, and I don't remember what they are, 1060.65 something. This is a 22-bit address, 255.255.252.0 is a subnet mask. Show a router here. The router is the router that's on the quote public network, unquote public network, the cloud router. You don't have to really worry about it. It then connects to the public address for your existing full install. The full install should have 2 NICs on it. One's on the public network, which right now is probably DHCP enabled, should be a 10.60.64 something address. And on the other side, 192.168.2, I want to just keep using that since we've already got it set up. And that will then connect, we'll call this the test network, 192.168.2. The other server over here should be your core server. The core server should be set to use the default gateway, the 192.168.2 address of your routing server. When you do the static IP address on your XP machine, the default gateway should be the interface, the public interface, and you're going to set it to a 10.60.65 address on your server, so that when it goes someplace, it's going to send it to the server is going to do the routing for you. We'll use this configuration to test both routing, remote access, NAT, as well as to do the VPN. So that's the topology. This image is in the lab itself. If you want to print it, write down the addresses, that's not a bad thing to do, because that's what usually confuses me the most, is what address do I have where in these things. Routing tables, we've seen routing tables. The way that you see a routing table in Windows is to use the route print command at the command line. It'll tell you where your route tables are. We'll look at that. Let's look at that quickly, just because we can. Here on this machine, route print, it's going to have a little bit of extra because it has VMware on it, so it's got the VMware switch addresses on it. But the default 0.0.0, the mask of 0.0.0, golly, as we would expect, goes to 10.62.11.1, the default gateway. The interface, 10.60.211.177, that's the interface it goes out of. That's the IP address on this machine. To get to the 10.60.211.0 network, the mask 255.255.255.0, to go to that network on link goes out to 10.60.211. Notice for the local network, it doesn't send it to the gateway. It says on link. On link means it's on this network, anything with that mask. And then we go on through 10.60.211.177. The mask 255.255.255.255 is the mask for an individual address, an individual IP address. On link goes out the 10.60.211.177. To get to the broadcast, 255.255.255 on link goes out to 10.60.211.177, its local address. And the 127.000.255.00127 and goes on 127.001. Each of those basically tells the packet whether to go someplace else or whether to look for it on link on its own network. And notice most of those are on link. The only thing is the default route goes someplace else, and one of the things that I do ask you to do in these labs is to do a default route 0.0.0 with the subnet mask of 0.0.0, and then send it to whatever the 10.60.64.1 is what the default gateway will be on that one, because it's to get out of the network and then see what happens. One of the things that I hope these activities that I kind of drag you through will demonstrate is the difference between routing and NAT. Many times as we say it, what's the difference between routing and NAT? Trying to get somewhere. Same thing with NAT. Preserving IP addresses. NAT actually puts a new IP address, source IP address in the header. Routing keeps the existing IP addresses. So it can be an issue and will be an issue, I'll tell you right now, when you get there, when you route in NAT, once you get off of your private network. Once you try to get to one of the, quote, public 10.60.64.1, the default gateway, you're going to have an issue. Because when you get to the 10.60.64.1, router doesn't know what to do with that packet. Actually, it does know what to do with that packet, but I disabled that NIC. I have ask them to put a default route in there that sends the networks that I use back to the gateways that I have established. So I have disabled the 192.168.2 network NIC on my router so that it won't break. I was working on this thing yesterday and said, this is not right. This shouldn't happen. Oh, yeah, I do have a path back. It would be what we would call a dual gateway, and that kind of, I think, demonstrates that you don't want dual gateways. You may not want duplicate paths. You may want duplicate paths, depending on what's going on. Because this one, if that one router had failed, you could have another path back, and it actually would work doing that. The only thing it did was mess me up for a while I was doing the labs. So the route print command shows us the routing table that's on the machine itself. Routes directed traffic to its destination based on information that it contains. Been there, done that. Hopefully static routes make some sense. You're not going to do any complex static routes in this one, just a default route. But this is one of those kind of follow in your mind, and I say become the packet people add. But think about, I need this information. I need to go here. How do I get there? You do the same thing when you use your GPS. The GPS itself internally knows the entire route to where you're going. Because you can look at the turns, right? But what does it tell you? What turns next? What does a router tell the packet? And depending on the protocol, I understand that it may or may not have the entire path, and that's the difference between IGRP and the higher level routing protocols and the simpler routing protocols, how much of the information is have. RIP just knows the next hop. IGRP had the whole routing table in it. OSPF had the whole routing table in it. Depending on how much is stored, whether it stored the backups or not, was one of the issues there. So it may or may not, but the only thing it really knows is where to go to next, which is exactly what the GPS tells you. Because if you tried to remember that whole route, it would be a mess, wouldn't it? Especially if you're going from here to Toronto or someplace like that. Routing tables managed in the routing and remote access console or from the command line using the route command, and the route add, route delete. If you, and it's good practice, I think, to use the command line, if you use the command line, you need to give it the persistent switch. If you don't tell it it's a persistent route, when the machine reboots, that route goes away. So it can be a persistent route or a non-persistent route. By default, they are not persistent routes. The commands, route print, route add, route change, route delete, the different things that we can use, and the language, the process, what all has to be in there. Route-P add 192.168.200.0 mask 255.255.255 192.168.200.1 would be the next hop, the default gateway of those things. The other thing, while I'm thinking about these, when you do routing, you should not have a default gateway on the NIC. The routing protocol is the one that should do that. It's probably not going to be that big a deal, but there are some cases, rare though they be, that the default gateway may override the route. So take the default gateway out of all of these NICs that you're going to use for routing. Configuring routes limited to the following. Manual creation, you've done that. Default routes are not very handy for very many routes. The static routes are not very handy for lots of routes. The default route is very handy if you have your network configured that way. Default route, send everything to someplace else. One of the other things to keep in mind about these is a default route will send everything that doesn't have a more specific route to the default. If you have, and if let's say we had 4 routes that we wanted to send to some other, to the private interface, we'll call them public and private interfaces, and everything else go to the public interface. Instead of trying to do everything, and golly, I bet you couldn't put all the addresses on the internet in there. I certainly couldn't. The default route sends everything except the 4 that we have more specific routes to the other interface out towards wherever the default route is. Dynamic routing protocols, we've seen that in Cisco. They do, and again, RIP is the only one that's still available in Windows. It works with broadcast, exchanges information with other routers, and yes, it will exchange information with a Cisco router or with anything else that's available to do that. RIP v2, partner routers, RIP neighbors, then determine the dynamic routing process. We've looked at that. Remember, RIP v2 is a class full protocol. RIP v1 is a classless protocol. The DHCP relay agent is there. When you get to that lab, don't worry about configuring DHCP relay agent. I want you to know it's there, what it does. But this is another, to me, are you going to set up a server to run as a DHCP relay agent? The answer is probably not, just like you wouldn't do a router. You're probably going to use your router as the DHCP relay agent, and that's what this really becomes part of in their process. But it manages the communication on networks between the DHCP server and the clients, like in here. There is no DHCP server in this room. How do we get addresses? Because the router is set up as a DHCP relay agent. DHCP relay agent, DHCP process, DORA, the discover packet goes out. The DHCP relay agent would intercept the discover packet. It would then forward it using a unicast, knows the IP address, to the DHCP server. The DHCP server would send it back to the relay agent. The relay agent would then broadcast the offer. And then the request and the acknowledge, same process. So it just intercepts and relays, and that's obviously relay agent. With routing and remote access, the network adapters are added and configured to listen for the broadcast messages. Which network are we going to listen on if you have more than one? And you can have multiple NICs, obviously. You can have multiple IP addresses on a single NIC, which can be handy, which can also be a pain. I think it's like 8. I don't know that I've ever gotten to that limit. Well, I think that the advantage here, and then they may have changed that, so don't quote me on that number. I guess where you would use this a lot is if you were, let's say that we were running a web server service. Each of our clients would have a unique IP address. If we wanted to have more than one web page, which we could, running on that machine, then we would have each of those web pages have a different IP address, which means that we would then have to have multiple IP addresses or multiple NICs, one or the other. And you can have multiple NICs, more than one IP address on the other one. Demand dial routing is still there. Is it going to be used frequently? Probably not. Demand dial routing is for something that is really, really isolated and really, really doesn't have any other capability. Are there places like that? Yeah, Mr. Matthews got a cousin that just had one. He got a lightning strike, burned the modem up. And that's the only thing that they have where they are on their farm is wireless. Is dial-up. I think it's wireless. You probably might be able to get satellite, relatively expensive, relatively slow. So this capability is here. And when we get to here in a couple minutes, VPN becomes a dial-in type protocol. It uses that service. You have to authorize the users to use the VPN using the dial-in capability. So it is still there. Dial-up networking, remote users to their networks using a standard phone line. We all know, probably experienced not the greatest thing in the world once we have cable or DSL or something else high speed. A VPN, virtual private network, virtually private network. The dial-up network is a private network. Who's on the connection, we hope, is the two endpoints. A VPN is virtually private because it uses a public network, this little thing we call the internet, to send information in a secure manner. It does that by using encryption. Story I learned a long time ago was one of the presidents, and I don't remember which one. They said that he and his wife, and they used to like to vacation in Hot Springs, Georgia, I guess. It wasn't Roosevelt. Harding, maybe. Would have private conversations because they both just spoke Chinese. And if you, that's the encryption to me. I don't know about you. You speak Chinese? No. Me too. So what we do is create an encrypted our own language packets and send them through the public network. Can they be intercepted and cracked? Eventually, yes. Is it an easy thing to do? Depending on which protocol you're using. Actually, it's not easy, but some of them are easier than others to use. So we allow connections to your network from remote locations. Where is this used in a lot of instances? Let's say you have salesmen that travel. Hotels now, except for the really expensive ones, now will give you free Wi-Fi, right? Usually Wi-Fi. Some of them still have wired. I think most of them have gone to wireless. So if they need to call back to the office, instead of having this enormous modem bank for dial-in, and then you have to pay the hotel charges for the phone call anyway, they connect through the wireless at the hotel and create a VPN, a virtual private network connection to the endpoint on the server, to the external facing interface. Get an IP address on the remote network, and now they're able to communicate on the network. The caution here is when somebody connects on a VPN, they're on your network. You need to be careful who you allow on that network. For that reason, the default connection capability is no. That's the default policy. If you don't have Active Directory or it's controlled by a policy and it's either yes or no, allow or don't allow, the default is no. So you have to make an effort to allow users to get onto your network via a VPN. There are some other things that have to be set up too, like the client. And those are the things that hopefully you do in these activities. Tunneling protocols, point-to-point, layer 2 tunneling protocol, secure socket tunneling protocol. The secure socket SSTP is something that's new in Server 2008. Handy from the standpoint that instead of having to open up 1723 and whatever all the other ports are for the regular VPN, it uses port 443, which is normally open on a network. Point-to-point tunneling protocol, very straightforward, very easy to set up. Doesn't require certificates. A layer 2 and SSTP, when you see those things, certificates, you got to have certificates of some sort in order to support those. And the ones that you do point-to-point, actually auto-select. Auto is who we're going to use, and auto is going to pick point-to-point tunneling protocol because it sets up in a straightforward manner. The window for this thing, general security, IPv4, v6, PPP logging, and again, when we get to these things, I want to go through the process of how you install each of them and how you configure each of them before you get to the labs where you're going to do these things. Point-to-point tunneling protocol, TCP 1723 for point-to-point practice, or point-to-point traffic, tunneling protocol traffic, VPN ports inbound and outbound, IP type 47 for generic routing encapsulation, GRE. You may or may not remember seeing that in the Cisco class. I think they probably one place a GRE, and it's what does it do, but it's the generic routing encapsulation. IP type 47 has to be open in order to be able to do that. Layer 2, you notice, gets a little more complex. UDP 500 for IKE traffic, Internet Key Exchange traffic. We're going to be more secure but also more complex in the setup. UDP 4500 for IPsec NAT T and IP protocol ID 50 for IPsec ESP encapsulated traffic, ESP encapsulation security payload. UDP 1701 for L2TP traffic. When you do the certification test, these are the kinds of the things that they love to ask. And since L2TP has a lot more that they can ask about, guess which ports they're going to ask about? They're there. UDP 4500, 4500. ID protocol, UDP 1701. SSTP, pretty straightforward, port 443 for SSL traffic. Secure socket layer traffic. The thing that will get you on that is you got to have certificates. And on the client machine, you have to trust the certificate that's on the server. The server, you put a certificate on, it sends its ID to the client. The client has to have that certificate authority. I'm going to get there as it goes through my brain. Certificate authority is a trusted certificate authority on it, which means that if you're running your own certificate authority in the domain, it'll work out because it'll be trusted. But if other users, they're going to have to go and manually install that certificate authority. Sorry, these sinuses are still fun time, but the advantage of this one, it is brand new. 443 is normally open. Disadvantage to this is we're talking Vista and Windows 7 here. So it's not like you're going to be able to go back with old clients and be able to use the SSTP. And it is new in Server 2008. NAT, been through that, allows you to shield the internal IP address from the public networks. One of the things that some people don't like about IPv6, since there are bazillions, that's what that guy, gazillion, that's what that guy was saving in the commercial for his retirement, right? Gazillions of the addresses, there's no NAT. Your addresses are viewable. Can somebody now map the addressing structure of your internal network? And since there's no NAT, this won't go away. Since there's no NAT available, they can then connect routed back directly to the workstations. One of the things that NAT does do for you, and hopefully will be demonstrated in the activities, provides isolation. What provides most of the protection for my Netgear router? NAT. The public address is out there. You can get up to the interface of the public address, and you probably have it configured to no log on and all that other good stuff. But once you get there, now what? Unless you can see the NAT table, you have no idea what the real address of the machine is. So NAT really is a great security component. Protects the internal addressing scheme, and that's what we always talk about, but it also prevents people from connecting from the backside unless you have a NAT going the other direction. And that's what you would do if you had your web server inside, for instance. You would have the public address, and it would be netted to an internal private address. Yeah, well, it's one of those that, well, I think IPv4 originally didn't have NAT because we're never going to run out of addresses. You know, when there were 12 or 14 computers in the world, that's a lot of addresses. But when you get millions of computers in the world, not so many addresses. Will they eventually run out of IPv6 addresses? Maybe, but not in my lifetime. Maybe in yours. Maybe in yours. Huh? Yeah. Well, it's more than just computers. It's more than just computers. What about all you guys with fancy cell phones? Do they have IP addresses? Yeah. What about in the more advanced areas of the world where the vending machine sends you its inventory? Do they have IP addresses? What about eventually when you start taking stuff out of your refrigerator, it's going to send you a shopping list? Is it going to have an IP address? There are more and more and more and more and more devices.
Oh, there's already like drink machines and stuff.
Yeah, drink machines. Well, the drink machines send inventory, and that's a good way to save money. But what about the ability to use your credit card in one of these remote devices, Redbox? Yeah. How are they going to charge that credit card? Got to be able to communicate with the database, right?
And all those gas stations.
All those gas pumps, and I think they all probably go back inside and then go out from a central location.
I don't know, because they take forever to take your money out.
Yeah. What about grocery stores?
I guess you could
What about inventory in grocery stores? I mean, all that stuff. I mean, just think there. Yes, there are more devices. And there's going to be even more devices because we got now all of these things that we never knew that we needed until Apple came up with the, the iPod with Wi-Fi and the iPad. And
they just give you an iPad and you order off.
And you order off.
It goes directly back to the
shelf. Back to the shelf. So
yeah.
more and more and more devices. Now those could, and if we use an IPv6 and there's no NAT, now there are private addresses. That's what the FE addresses are. The link local addresses are the equivalent of. Yeah, FE0 are the equivalent of the private IP addresses, but they generate them. They generate those themselves. So NAT, okay, we already did that, right? NAT puts a new IP address in the header. The difference between NAT and PAT, NAT, true NAT, each of the devices gets a unique public address. PAT, we use a single address, what you and I use at home. We have I have at least a, 1995, 2995 router that gets a single IP address from Cox, and I can now run 3 or 4 machines, and I think that they say 4 is the limit if you go back and read the license. From that same IP address, but they have different ports, different sockets, so that the information knows where to come back to. And that is the key here. And what we're really going to configure on our servers, we're going to call it NAT, but it's really going to be PAT because we're only going to use a single IP address in order to do that. The network policy server, role service that provides a framework for creating and enforcing network access policies for client health. So we're going to use this thing in order to control access, remote access to our network. Can be used to perform, configure the radius server, configure radius proxy, configure and implement network access protection. Network access protection is really an improvement in allowing users to access your network. What network access protection does on your, and I think it's XP Service Pack 3 Vista Windows 7, and there's a client that has to be enabled on these things, basically checks your security center. Do you have an antivirus software? Is the antivirus software up to date? Do you have automatic updates turned on? Has your machine been updated? And a couple of other things. And if it doesn't, there are a number of ways to configure this. The simplest one is DHCP. What it does gives you an address without a default gateway, or only allows you to go to a specific server. Gives you access to what they call a remediation server, something that's got the files that you need in order to update your antivirus, in order to update your Windows update so that it brings you up to date. Once you get updated, it keeps checking your machine. Once you get updated, it'll put you on the public, the internal network on the machine, give you an address on it, so that we can control access. The radius server, they make a big deal about it, and they used to call this IAS, Internet Authentication Server. If you see that, it's radius. I guess that they finally decided that they can call radius server because about the only thing you can do with Internet Authentication Server is do these policies and turn on radius server. And again, if you watch the little video, show you how the radius server, step-by-step configuration, and then what we can do with it. And it's just one of the things that we can do. There are others. That's one of the things. What it does is authenticates. When you go to something, the client, and in this case, and they mix terms in this chapter. They talk about a client and they talk about an access client. In this instance, the computer that's trying to connect somewhere should be called the supplicant. The supplicant goes to the, and let's say that on the one that we're going to use, we are on a wireless. We have a wireless NIC in our computer, and we want to get on the wireless access point. The wireless access point is going to be the client. The wireless computer is going to be the supplicant. The wireless computer asks the wireless access point, the client, for an IP address. The wireless access point then, using the radius server, asks the radius server then searches the Active Directory database to see if I'm legitimate, see if I can actually log on. A radius proxy, if you have a lot of different radius servers, you can use a radius proxy. The radius server, if you have a centralized database, that actually should work pretty well for the eCPI universe, shouldn't it, for real? We could have a radius server that's set in Virginia Beach that's centrally authenticated everybody to all the resources. Not necessarily the greatest thing in the world. They use Active Directory for that, but this radius generally for access from outside. You can configure it. They've got some activities. I don't think that I may have asked you to install it and just do a configuration if you watch the video. It's not a complex. You've got a shared secret, a bunch of other stuff in order to do that. Central utility for managing the NPS console, for managing radius clients, radius servers, network health and access policies, NAP settings for NAP scenarios, and logging settings. So a centralized console to manage all these things. And it's like most of the stuff that you do now, you can do it out of Server Manager or you can do it out of the administrative tools. They both do this for us. Radius is the industry standard. I think I probably covered most of this already. That provides centralized authentication, authorization, and accounting for network access devices. So authentication and authorization. What's the difference? Authentication is when you prove who you are. Authorization is when you get access to use something. You're authorized to do whatever else. And accounting for network access devices. Accounting where you're going to log the information. Components of Radius, the Radius clients, the network access servers, the Radius proxy, the Radius server, user account database. Notice how they deftly avoided the who wants to get on, the supplicant. The client in this case, the client in the case that Radius client in the case that I talked about, the wireless access point, the client's the wireless access point. The network access server is the Active Directory server. The Radius proxy, if we have one, is a service running on one of those servers, and the Radius server is a service running on one of those servers. Frequently, the Radius server and the network access may be the same server. Active Directory, the demo that I use, are both in the same location. They don't have to be, but they can be. And then user account database, we're talking again here, Active Directory. The components of this thing. Kind of a wild picture here. Goes a little bit everywhere. Wireless users, a wireless access point, the 802.1x device, and they should have put a space in here. The 802.1x is not part of the wireless. It's a wireless or a wired access. So it's not the 802.11. It is 802.1x. And X is not a variable in this case. You normally would put X in, but something's can go in there. That's the protocol, 802.1x. Goes to the Radius proxy. The Radius proxy then sends the information to the Radius server. The Radius server would query the domain controller. You get a simple yes, no. Sends it back to the Radius server and all this stuff, and back to the wireless access point, which in this case is going to be the client. The reason they're showing a Radius proxy here is we have multiple types of access. And VPN server, network access server, the Radius proxy may, I think there's a little bit more, I thought we were more in this next one, may have to pick which of the Radius servers it sends the information to. You might have a Radius server for dial-in, a Radius server for VPN, a Radius server for wireless, and the proxy would then determine which one to do the authentication from. That would be in a really large network. Changed, not a whole lot looked like it changed here, did it? This is actually the new slide, but what changed is we don't have the proxy, the radius proxy anymore. All of the requests, all of the queries go to the radius server. The radius server then answers the clients. Each of these things, the RRAS network access server, the network access server, the wireless access point, are all going to be the clients for the radius server. They'll be the radius clients. The radius messages, access request, accept, reject. We have in the past, because we weren't really good at it, had issues that, boy, it looked like everything was really good, but it wouldn't work. And what my problem has typically been when it looked really good and it wouldn't work is the certificate wasn't correctly configured, because you do have to have a certificate. You have to trust the server that you're logging into. You can set up Wireshark and see which messages you get and where in the authentication process it fails. So you can see all of that, and all the exchanges will take place before you get authenticated. Once you get authenticated, then you get the IP address. Same thing on the wired switch. The port's actually turned off, but it allows all of this communication to go through the non-enabled port. This is what goes on. This is the kind of stuff that you would see in a Wireshark. The supplicant, see, we finally got to the right word. The supplicant system, EA, Extensible Authentication Protocol, EAPOL, goes to the switch to the radius server. They show an error here. The start request, the switch will request, here we go. We're going to send the request to the switch. The switch comes back and says, who are you? Give me your username and password, EAP response identity. The switch then forwards that information to the radius server. The radius server, radius accessor, sends the challenge back. And remember, the challenge is used in order to be the seed, I guess, for sending the password, so that you're not just sending an encrypted, well, you're not sending an encrypted password. You use it along with the password in order to create the response. So the EAP response to the challenge, if it's good, we get the success. Once we get to the success, port is accepted. Either gives yes, we're on the wireless access point, the port gets turned on the switch, and then we can get the IP address. I think what really is a big deal about 802.1x is that you can't get an IP address until you get authenticated. So you're not on that network at all until that happens. Authorization and accounting, and I don't know how many times we can say that, can be an NPS, which replaces the IAS, Internet Authentication Server, from previous versions of Windows. IAS was just a fancy name for Radius, as far as I can tell. It was always, the service that we always used in it was Radius, but they have accepted it now and named it Radius. Radius is a standardized protocol. Does not necessarily have to be, doesn't have to be a Microsoft one. When you do the configuration, there's some drop downs. If you have something that you're using specifically, some manufacturer type, you may pick that as the Radius, but generally just the Radius generic is going to work for what you want to do. Radius proxy we looked at can be configured as a Radius proxy. The server itself can either be a Radius server or a Radius proxy. The Radius proxy just simply refers the request to somebody else, just like a proxy server does. The proxy doesn't refer it. It does the action for you. Network access protection, tool for you to block external and internal network threats. This can be used both internally and externally, so that if you had machines in your network that weren't getting updated, they might get put into the quarantine network until they got updated. Doing a course and said all it takes is one little virus to really mess your network up. And that's true. If these things get viruses, don't have the up-to-date identities, then we may get into a situation that we've done damage to our network from our own machines internally. Which is one of the controls. The NAP, access protection, 3 components: the health policy validation, the health policy compliant, and limited access. What you do is define how extensively you want this to be, to impact your network. And then once that happens, you set it up to that the machines have to have, again, the client activated. Once the clients are activated, then it does the checking. This was available. They say this is new in Windows Server 2008, and it kind of is. The actual ability to configure it is there. They had a process in Server 2003 which would probably take about 8 days to do. It was not a simple process that this would work. And there was a client that you could put on the XP machines that would make it work. So, yeah, it's been around, but yeah, you probably can actually get it configured now in Server 2008. Authentication protocol, EAP, Extensible Authentication Protocol, Transport Security, EAP, TLS, PEEP, and if you watch the video, PEEP, Protected Extensible Authentication Protocol, is the one that is used in that particular one. You pick the protocols that you want. When you get into security, you can have more than one protocol that it tries to negotiate. And what these things will do is try to negotiate security. You're going to start out with the highest level of security, and they will attempt to negotiate. If that doesn't work, they'll move down to the next layer, and down to the next layer, and down to the next layer. If you don't have a common protocol on both machines, they just give up. You don't complete the connection. The wireless, the 802.1x, which I've talked about a little bit already. Network access control provides authentication mechanism to allow or deny access based on a port connection. Again, 802.1x, not just a wireless. It actually was originally a wired protocol and is now used in wireless. It's available both wired and wireless. You can use it on a Cisco product to not turn the port on until you actually get authenticated to the network. Wireless access point, same way. There are other protocols that can be used on wireless access points. Cisco has some that they put in there. So they have some Cisco proprietary that kind of look like this but are a little bit different protocol. EAP over LAN and EAP over wireless. When we're talking about extensible EAP protocols, kind of think along the lines that we're probably going to have a certificate of some kind in here. Certificates make the setup a little more complex. They also make the setup a little more secure. So we may have those. This is same picture, isn't it? Wireless access point. We would go here. I turn on my computer. I try to get an IP address from the wireless access point. The wireless access point goes to the radius proxy. The radius proxy refers the request using all of those exchanges that we saw earlier to the radius server. The radius server then checks with the domain controller. Are we real? If we are, sends the OK back, the okie dokie back to the wireless access point, then gives us an IP address. It doesn't turn anything on or off. So writing remote access is a way to set it up. There are lots of services. I think probably the one that, in a realistic standpoint, that you would use the most is the VPN to allow users to connect to your network. You can make it a router. It can be used as, I think, probably as a temporary router. I don't know that you're going to set a server up to be a router, except in a circumstance like I have with the virtual machines. I use it as a router constantly. But are you going in your business? Yeah, I don't know. I mean, what does a router cost? A small business router cost? Under $100? Server's probably going to cost you more than that. So routers we know about, the processing of traffic. Routers, dynamic protocols, and again, the only one that carried forward in Windows is RIP. DHCP broadcast messages, the DHCP relay agent is what we're talking about there. You can set up a relay agent on a server and have it do that, or you can set up a relay agent generally on a router also. Demand dial routing you may need to do. The thing about demand dial-in or dial-in routing is VPN is a dial-in service. You have to be authorized dial-in before it's going to work. VPNs and NAT we talked about, you've looked at that. NAT, PAT, shield the internal IP addressing scheme. It also serves as a security component, and when you do the NAT portion of the exercise, the activity, try it out. See what happens. See if you can get into your network. Don't spend a lot of time trying to see if you can get into your network, but NAT is a very good protection in addition to the firewall. Actually, that's what mostly the firewall is on the Netgears, is NAT. NAT, network access protection, block external and internal network threats, checks basically the security center of the machine to see if you're up to date on updates and if you have an antivirus and the antivirus is up to date. Are there questions? And I'll quit. Let's take a break. When we get back, we'll take a look at how to configure some of these things.